Well, we have already discussed Ohm's law. Now we revisit this Ohm's law, and now we'll clear some doubts. Ohm's law is very basic and important in electrical science, but the beginners usually find it difficult to understand. If you understand, then that is good, but if you do not understand, then you are more rational, and we hope that now your doubt will be cleared to a great extent. And this is the Ohm's law circuit. Here you can see a conductor connected with a battery here, and these are the connecting leads between AC. This is CD is the terminal of the conductor and battery terminal AB, and these two connecting leads are connecting the conductor and the battery. This configuration is read on here as a electrical equivalent circuit. This is the circuit of this this configuration. So in this configuration, what is the supply voltage? This is the battery voltage V, and this voltage is applied across the resistance R, and in the Ohm's law we said that this battery voltage is across the resistance, that is V, and current I will flow through the resistance. So current is directly proportional to the voltage, and finally we deduce the formula that I is equal to V divided by R. V is the voltage across the resistance and R is the resistance. This conductor is shown here as R, and this battery is shown here as this by this symbol. Now the students usually ask question that they are knowing that the current flows from higher potential to lower potential. Then if this voltage is V, then this is V. So how the current will flow? The teachers find it difficult to answer the beginners this type of question. Moreover, if this is a conductor, this is shown by R, then what is this? This person A to C, and this D, B, this person, that is also conductor. Then why it is not shown by some resistance? So to this type of question, actually it is very difficult to make the students understand this, because they are not having sufficient knowledge. And the thing is that to understand this, you have to know more about the electric circuit. Now we have gained sufficient knowledge, and I recommend you to consider my last videos, like series parallel connection, especially the series connection of resistances. Let us discuss this. So this is a conductor. These are actually connecting leads, and these connecting leads are having very small resistances. Everything you see around you is having some resistance. Something is having more resistance and something is having less resistance. Here these resistances are low, but we will now consider this, and let us redraw this circuit considering those lead resistances. And this is the circuit so formed. These are the lead resistances. These are this person A to C is having some resistance, and it is shown here, and A to D, sorry, B to D is shown here. Let us now let this resistance be R1 and this resistance is R2 and this is R. Let us take some value and solve the circuit. That this resistance R is, this is 10 ohm, and R1 is, let this be 0.01 ohm. This R2 is 0.01 ohm. Same we have taken. Now what is the, now let this current flowing is I. Now the current flowing through the resistance, through these resistances, through the circuit is I, that is voltage V divided by R equivalent. This is R equivalent. Now what is R equivalent? R equivalent is equal to how much? That is R plus R1 plus R2, that is equal to 10 plus R1 is 0.01 plus R2 is 0.01, that is equal to 10.02 ohm. So I is equal to V. Suppose this voltage V is, this is suppose 20 volt. Now I is equal to 20 divided by R equivalent is 10.02, this volt by ohm, that is equal to that we have calculated this as 1.996 ampere. This is the current that is flowing through this circuit, or you can say in this circuit, the same circuit, this current is flowing. Now what is the voltage across this resistances? Suppose this voltage across this is V dash, and voltage across R1 is this is how to say, this is V1, and voltage this R2 is, this is suppose V2. Now what is V1? V1 is equal to I R1, that is equal to I is 1.996 ampere into R1 is 0.01 ohm. How much we get? That is equal to 0.01996, 0.01996 volts. Similarly, V2 is equal to IR2, that is equal to 1.996 ampere into 0.01 ohm, that is equal to 0.01996 volts. And what is V dash? V dash is the voltage across this resistance. This V dash is equal to 1.996. This current into resistance R, that is equal to 10. So it is equal to 19.96 volt. So here we have applied the Ohm's law to all the resistances individually. That what we have solved in previous problems. You can refer to those problems. I recommend you to see those problems. You can see that this voltages V1 and V2, they are very low, that is 0.01996 volts. V1 is 0.01996 volt and V2 is also the same voltage. But V dash is equal to 19.96 volt. That means you can see that this 19.96 is very close to 20 volt. So this voltage is never same as this voltage, but this is an approximation, that is almost equal to 20 volt. That's why what we did in the Ohm's law, I is equal to V, that is 20 divided by R, that is R is equal to 10 ohm. That is how much I get? That is 2 ampere. That is, you can see that this current is 1.996 ampere, that is very close to 2 ampere. So rather than calculating this, because here you can see that decimal points are there and it is easier to calculate, and this is also practical. You can see that in this resistance also its value is 10 ohm. Its accuracy is something maybe 2%, 3%. That means this resistance is also not exactly 10 ohm. That may be 9.96, 98 like that, or and this it may be 10.1, 10.2, anything like that. So in comparison to that resistance, these resistances are very small, so they may be ignored. So practically we can consider this voltage is equal to this voltage, but actually this voltage is slightly lower than this voltage. By how much low? You can see it 20 minus 19.96 volt. that is the voltage drop across these resistances. Okay, but you can see that this V1 divided by R1, that is equal to this V2 divided by R2, that is equal to this V dash divided by R, that is equal to I. Okay, you can see that V dash divided by R, that is how much? 19.96 by R 10, that is equal to 1.996. This is the current. And V1 divided by R1, that is equal to I, that is equal to same, that is equal to V2 by R2, that is equal to how much? The voltage is 0.01996 divided by R2. R2 is R1 or R2, 0. They are the same, R1 and R2 and V1, because we have taken the same resistance. So this ratio is same as this ratio. They are equal to 1.996. So this voltage divided by this resistance is equal to this voltage divided by this resistance, that is equal to this voltage divided by this resistance. Although these values are small, but their ratio is the same as this. This is bigger by bigger voltage by bigger resistance is equal to smaller voltage by smaller resistance, but the ratio is same, that is equal to the current I that flows through the resistance. So this voltage across the resistance, that is not equal to the voltage across the battery, but for simplification we take this voltage is same as this. So in the electrical circuit, while solving the circuit, this connecting lead voltage drop across the connecting lead are considered as negligible. So it is usually taken as 0, but it is not 0, it is very low, that is negligible. So this voltage appears across this resistance. So nothing is perfect. Complete electrical and other engineering, then real world problem, this approximation is used and it works well. So discretization, lumping these values, this is lumping, this resistance is lumped at one point. This is the common practices followed in real world problem solving. That's all for now, and we'll discuss more next time. We'll most likely discuss more about the voltmeter and ammeter connection in Ohm's law circuit. That's all now.